Okay, the first step in the first problem is to determine how much sodium chloride it would take to make the entire prescription volume of 50 mils isotonic. So 0.9 grams NaCl per 100 mils is isotonic. So how many grams NaCl to make 50 mils isotonic? That will be 0.45 grams NaCl. And then we factor in the contribution of the ephedrine sulfate. And the ephedrine sulfate has an E-value of 0.23 grams NaCl, represented by every 1 gram of ephedrine sulfate. And we have, we have 0.25 grams of ephedrine sulfate, and want to know how many grams of NaCl that represents. So X equals 0.0575 grams of NaCl. Okay, so the amount of NaCl that we would need to add is 0.45 minus the contribution from the ephedrine sulfate, and that will give 0.3725 grams NaCl to add. Okay, but we want to actually add potassium chloride, and so hopefully you're not intimidated by having that there, because we actually don't deal with it until the end of the calculation. We always just calculate how much NaCl to add first, and then we will figure out how much potassium chloride to add after that. So we can use the E-value of potassium chloride. 1 gram potassium chloride represents 0.76 grams NaCl. So how many grams of potassium chloride are represented by 0.3725 grams NaCl? And X for that is 0.49 grams, which we can convert to milligrams by multiplying by 1,000. So we have 490 milligrams of KCl that should be added. Okay, so we'll put in 0.25 grams of ephedrine sulfate, and we'll add 490 milligrams KCl. We'll add enough water to get to 50 mils, and that should provide the isotonic ephedrine sulfate solution. Okay, next problem, same kind of thing. We don't want to be thrown off by the fact that we're using potassium chloride as the agent for making the solution isotonic, or that it's a 5% solution that we're using. All of that we'll take care of at the end. At the beginning, we just have to worry about how much NaCl would we add. So the isotonic concentration of sodium chloride is 0.9. And so how many grams NaCl would be needed to make 30 mils isotonic? And the answer there is 0.27 grams of NaCl. Then we have to account for the contribution of the chromolan sodium, which is a solution this time. It's 4 grams chromolan sodium per 100 mils of solution. So how much chromolan sodium is in 30 mils of solution? And X equals 1.2 grams chromolan sodium. And we want to know how much sodium chloride that would contribute to the solution. So we use its E-value, which is given here, 0.11 grams of NaCl is represented by 1 gram chromolan sodium. So how many grams NaCl is going to be represented by the 1.2 grams that we have in there? X equals, I get 0.132 grams NaCl. So the actual amount of sodium chloride would need to add with the chromal and sodium in there is the 0.27 minus contribution of chromal and sodium, which gives 0.138 grams NaCl to add. Okay, now we can worry about the potassium chloride. The first part is just like in problem 1. We'll determine the mass to add based on the E value for KCl. We want to add 0.138 grams of NaCl and want to know how many grams of KCl is that. And the value after crisscrossing and dividing should be 0.182 grams KCl. And then we want to deliver that in the form of a solution. So if we have 0.182 grams KCl, how many mils of the 5% solution do we need if there are 5 grams of KCl in 100 mils of solution? So X gives us 3.6 milliliters.